Now let's check the last video of chapter 2. Just summarizing the numeric data types. So Rust provides several data types with clearly defined sizes. So all the signed integers use the letter I, while all the unsigned integers start with letter U. And the number following the letter specifies the number of bits. For example, I32 is a 32-bit signed integer, while U32 is a 32-bit unsigned integer. So, Rust provides I8, I16, I32, I64, I128 along with their unsigned equivalents. Now, floating point numbers. So they use F32 and F64 and they represent 32-bit and 64-bit floating point values. So what's the advantage of this? What's the advantage of this, right? Like I32 always being 32 bits. Similarly for others. So what's the advantage? Advantage of Rust fixed width integer types is portability, as we discussed earlier. A type such as I32 always represents a 32-bit signed integer. So regardless of any operating system or compiler or processor architecture, whether the program is compiled for Windows or for Linux or Mac OS or some other 32-bit embedded device or a 64-bit server, I32 always occupies 32 bits and provides the same range of values. So this consistency makes Rust programs easier to write and test and also port across multiple platforms, because now developers need not have to worry about integer sizes changing between systems. So in case of C, it is little different. So for example, if you take long, the data type long, right? So it depends on the target platform and compiler. So for example, this long data type is 4 bytes on 32-bit Windows. It's also 4 bytes on 64-bit Windows. However, it's 8 bytes on many Linux, 64-bit Linux and Mac OS systems. So this means the same C program can use different amounts of memory and support various different value ranges depending upon where it is compiled. So Rust avoids this kind of confusion by providing fixed width types such as I32, U64, F32 and several others that we saw now. So it makes the program predictable and portable. The next one is default values. So when no type information is present, like see, let count equal to 10, then Rust defaults this to I32 type. So Rust does not select the smallest type. See, for 10, it's enough to have I8, but it still selects I32 is the default. And similarly, for floating point, if there is no type information, it defaults to F64. So the next one is usize and isize. So these are all special integer types. So the size depends upon the target architecture. So for example, all the ones we discussed above, they were all fixed types, right? But however, usize and isize are special types and their size differs and depends upon the target architecture. For example, on a 32-bit system, they are always 32 bits in width. On a 64-bit system, they are 64 bits wide. Okay, so unlike what we discussed, I32 or U32, where sizes are fixed, usize and isize automatically match the native pointer size of the platform and they are used for array indexing. Okay, so this is one difference you need to know. So Rust provides both fixed type across platforms and target dependent sizes as well. Okay, I think that's all. This is just a comparison that we have between C and Rust. So one of the challenges I faced while learning Rust is, Rust documentation is very vast. It's like an ocean. And to search a small thing, you have to really go through the ocean. And that was the challenging part. And AI tools were helping, but it's not structured, right? You want everything to be in one place, go through a flow. So that part was missing. And that's one of the reasons this book is written, to make only things which are necessary. We don't want to learn the entire ocean. We only want to build the depth and not width, right? So once you know these things, you know all the data types. Okay, I think this marks the end of chapter 2, and now let's go to chapter 3.